Our third law is Avogadro's law, which says that at constant temperature and pressure, the volume of a gas is directly proportional to the number of moles of the gas. So what that's saying is that the more moles of gas you put into a container, the larger the volume will become, assuming the volume can expand. Let me give you an example. Let's say you have 20 liters of a gas, and that is 1 mole of the gas. If you double the moles to 2 moles, that would double the volume to 40 liters. If you double it again to 4 moles, that would double the volume again to 80 liters. So what Avogadro discovered was that if he took the volume of the gas and divided it by the number of moles, we're going to say N, we're going to use N to represent moles, he would get a constant number, just like Boyle did and just like Charles did. So for instance, we have 20 liters divided by 1 mole gives us 20. 40 liters divided by 2 moles gives us 20. 80 liters divided by 4 moles gives us 20. So for this particular gas at this particular temperature and pressure, we would get a constant number of 20. Knowing that, he could say then that the volume V1 over N1 is equal to V2 over N2. In other words, this one is equal to this one. So if we have a certain number of moles at a certain volume and we change the volume, we can calculate how many moles it would take to fill the new volume. Or if we change the number of moles, we can calculate what the new volume would be. So I'm going to erase some of this and we're going to do an example of Avogadro's law. This is example 13.7, page 414. And it says we have a 12.2 liter sample of a half mole of oxygen at a pressure of 1 atmosphere and a temperature of 25 degrees. What is the volume if the O2 is converted to O3? So the first thing I want to do is write down the equation of what's happening here. We're taking oxygen gas and we're converting it to O3, which is ozone. So we're going from 3 moles of oxygen to 2 moles of ozone. So they tell us that we have a half of mole of this at a volume of 12.2 liters. And we are going to calculate the new volume after this reaction is complete. So let's write down what we have. We have a volume of V1 of 12.2, and we're trying to find V2. We're given moles of oxygen as 0.5. Put a little O2 there. And we want to find out what the moles of O3 would be. Because we can't calculate the volume, the second volume, until we know how many moles we would have of this. But we have a way to find out because we can use our molar ratios to calculate the moles that we're going to form. So you take the 0.5 moles of O2, use your molar ratio, 3 moles of O2 to 2 moles of O3, and that's going to give you how many moles of O3 you've made. And when you plug those numbers in, you get 0.3 moles of O3. Okay, so now we have a third of a mole here. So we haven't changed the number of oxygen atoms that we actually have, but we have changed the number of moles of molecules that we have. Over here we have a half a mole of O2 molecules. Over here we have a third of a mole of O3 molecules. According to Avagadro, if we decrease the number of moles, we're going to decrease the volume. So this volume should be less than the volume that we started with. So our formula for Avogadro's law is V1 over N1 equals V2 over N2. We need to solve for V2. We've already calculated the number of moles that we have. In order to solve for V2, we multiply both sides by N2 rather. Those cancel, and now we have N2 times V1 divided by N1 equals V2. Now we just take those numbers and plug them in. N2, put my little numbers, so N2 is 0.33 because we just calculated that. So 0.33 moles of O3 times V1, which is 12.2 liters, and that's actually O2, and then divided by N1, which is a half a mole of O2. Okay, then you go through and make your cancellations. O2 and O2 cancel, mole and mole cancel, and so you're left with liters of O3, which is exactly what we're looking for. Plug those numbers into your calculator, and you will get 8.1 liters of O3. So our new volume is going to be 8.1 liters. We started with 12. We have reduced the volume. We started with a half a mole. We reduced the number of moles to a third of a mole, from a half to a third, and so the volume is going down proportionally. If we reduce the moles, we're going to get a reduced volume, and we see that that's what we get in this example.